Hello everyone, my name is Boyd and this is my devlog. In this devlog I will be showing you what I've done during the first sprint when working on this project. For the first sprint I decided to work on the player. I had to make the player be able to move and look around. First I'll be explaining how the first person camera works. So basically how the script works is we store the player's mouse input in these two floats called mouse X and mouse Y by using the getAxis function. Then we multiply the input by sensitivity so that the player doesn't look around super slow. Then we also multiply it by time.delta time so that the speed at which the camera moves isn't frame rate dependent. Then there's also a float called X rotation which we subtract by mouse Y. The reason we subtract here is because when we add mouse Y to X rotation the camera goes the opposite direction and we don't want that. Then we clamp the X rotation because we don't want the player to endlessly rotate the camera so far that the player can look behind himself. And then at last we apply the rotation to the camera's transform. Then for the Y rotation I made a transform for the player's body. I used the function rotate and in this function I multiplied the mouse X value by vector.up, because we want the player to rotate around the Y axis. After I was done with the camera script it was time to get working on the player movement. The player had to be able to walk around in the level and be able to jump. At first I wanted to use the character controller component built into Unity, because this required less time coding the movement and is generally easier to use. But since we use physics in the first level, I resorted to using the rigid body component, because this component is better when you want to include physics in your game. For the player to move I needed something to store the player's input, so I used these two floats called horizontal movement and vertical movement. Using the getAxis raw function. Basically what the getAxis raw function does, it returns either a 1 or a -1 depending on what key you press. So for the horizontal movement if you press A it returns a -1 and if you press a D it returns 1. And that's the same with the vertical movement but with W and A. Move direction determines the direction the player moves in. So it can either go forward or backwards or left or right depending on what keys they press. To actually move the player I added force to the move direction. I made it so that for each situation the player has a different speed. The move player function is in the fixed update, because the fixed update function has the frequency of the physics system and the movement of our player is physics based. This way the movement will look smooth. The reason I added normalized is because it ensures the magnitude is just 1, as is explained in this photo. With only move direction the player doesn't handle slopes very well. To fix this I made a boolean to check if the player is on the slope using a raycast. This function sends a raycast down from the player position and the output is set as slope hit. Then we check if the slope hit normal isn't up, and if this is the case the function returns true. This is because when the normal of a surface isn't pointing straight up, it means the player is on the slope. To calculate the direction when the player is on the slope I use the project on plane function, right here. This function projects a vector 3 defined by a normal that is perpendicular to the surface. Then in the move player function I added force to the direction of the slope the player is standing on. For the jumping I had to check if the player is grounded, otherwise the player could jump infinitely. So I made a boolean called isGrounded. For checking if the player is grounded I used physics.checkSphere. The sphere is positioned at the ground check position, which is slightly under the player, with a radius of ground distance. The boolean only returns as true if the object the sphere is colliding with is on the ground layer. In the jump function we check if the player is grounded, and if he is, the player jumps using add force. The force mode is impulsive because we want to add a sudden force to the player using its mass. The second line of code is there because of a bug. The player would sometimes make a smaller jump than usual. This happened when the player jumped, but the Y velocity wasn't 0 yet, because the player hasn't touched the ground. With this line of code the velocity will be set to 0, so the player won't have these smaller jumps anymore. There was another bug I encountered when testing the movement. The player could get stuck when jumping onto a wall like this. To fix this I added a second smaller but wider collider to the body and gave it a physics material with 0 friction, right here. And if I enable it, you can see that the player isn't stuck on the wall anymore. Subscribe to get updated on the progression of our game. The link to our itch.io page is in the description and I hope to see you for the release of our game. This has been my devlog, I hope you enjoyed.